Dawn breaks over the Cambodian jungle. Beneath this mist lies the skeleton of the largest medieval city on Earth. For centuries, the outside world had no record of how a metropolis this massive simply vanished. This visualization compares the population of the Khmer Empire's capital to medieval London. While London housed fewer than 100,000 people, a staggering 1 million residents lived and worked in Angkor at its peak. The physical footprint of this metropolis was equally massive. Its builders quarried and placed more total stone than the Egyptian pyramids, spreading across a land area larger than modern Paris. Yet by the 15th century, the inhabitants were gone. Over the next 400 years, the tropical forest consumed the streets and engulfed the temples, erasing the empire from the historical record until 19th century explorers reached the ruins. Early explorers found overgrown terrace towers in total ruin. Seeing these dilapidated stone peaks, a daunting physical mystery emerged: how a pre-industrial society could possibly raise such a colossal structure in the middle of a dense tropical forest. The stone monuments are merely the surviving skeleton of a highly complex machine. To understand how this civilization thrived, we have to look past the religious architecture and examine the extraordinary engineering that tamed an unforgiving landscape. Building in a tropical floodplain presents a massive structural problem. The Khmer architects set out to construct the heaviest religious monument ever conceived on a flat layer of soft, shifting sand. Their solution surrounded the temple itself. The immense 200-meter-wide moats encircling the complex were active engineering components rather than defensive fortifications. This cross-section illustrates the hidden physics beneath the temple floor. The moats constantly feed water into the compacted sand layer below. This continuous moisture locks the sand grains together, turning loose soil into a solid foundation. With the foundation secured, an even more staggering challenge remained. Even with a labor force numbering in the hundreds of thousands, laying millions of stone blocks using traditional methods would take centuries. Yet builders finished the entire Angkor Wat complex in just 37 years. To accelerate the pace, the architects utilized a material shortcut. They constructed the inner structural cores of the temples using laterite, an iron-rich rock that is soft and easy to cut when freshly quarried. They only used the dense, labor-intensive sandstone for the outer visible facade. Mastering the hidden mechanics of local geology and hydrology was the only way to build at a speed matching the ambition of its kings. Even with laterite cores, millions of tons of sandstone still had to be sourced from quarries located up to 40 kilometers away. Dragging that much heavy rock over land through thick brush was a logistical impossibility. The engineers bypassed the forest floor entirely. They excavated an extensive network of canals connecting the distant quarries directly to the city center, allowing workers to float millions of stone blocks downstream on bamboo rafts. Once those blocks arrived at the site, they had to be lifted into place. Modern 3D photogrammetry scans of the ruins have identified hundreds of tiny, uniform holes carved directly into the sides of the individual sandstone blocks. These divots were specifically sized for heavy wooden pegs. By inserting these sticks into either side of a block, a team could hoist and maneuver the multi-ton stones with precision, sliding them into position without relying on sheer brute force. Raising those blocks to construct the 65-meter central towers posed a final vertical challenge. Because traditional wooden scaffolding would snap under the weight, laborers built massive earthen ramps to drag the stones to the peaks, dismantling the soil only when the towers were complete. Angkor Wat represents an industrialized, highly organized engineering operation that demanded total control over the physical landscape. The massive stone temples were essentially just the downtown civic centers. The surrounding residential neighborhoods that housed the city's 1 million citizens were built of wood, which rotted away in the humid tropical environment centuries ago. To find where those people lived, researchers used LiDAR technology. Attached to helicopters, these scanners fire light pulses that slip through the dense jungle canopy. These laser scans revealed a hidden 2,000 square kilometer urban grid. Overlaying this is a massive hydraulic infrastructure. Enormous man-made reservoirs fed an interconnected canal system, sustaining the population through intense dry seasons. The Khmer Empire engineered a sprawling, interconnected megalopolis that completely restructured the natural environment to suit human needs. The water management system that allowed the Khmer to flourish ultimately became their most fatal vulnerability. Paleoclimate data reveals that during the 14th and 15th centuries, Southeast Asia experienced severe environmental shifts. Decades of parching droughts were abruptly interrupted by catastrophic monsoon flooding. This flowchart demonstrates the resulting cascade of hydraulic failures. The extreme monsoon surges overwhelmed the system, choking the distribution canals with silt and ultimately breaching the massive reservoirs. When a city relies entirely on a hyper-engineered infrastructure, it becomes inherently fragile. As the environmental baseline shifted well beyond the original design limits, the artificial ecosystem fractured. With their agricultural base collapsing, the crippled city faced intense external pressure. Military invasions from the neighboring Ayutthaya kingdom put additional strain on the already fractured empire. Pollen and sediment analysis confirms this wasn't a sudden magical exodus. Over several generations, as the water system clogged and the food supply failed, the million residents progressively moved south toward more stable trade routes. Without humans to maintain the canals and clear the brush, the jungle immediately began its reclamation process. Over the next 4 centuries, aggressive tree roots tore through the stone blocks, swallowing the great monuments in darkness. While we have uncovered the main temple complex, modern laser scans prove the forest canopy still obscures massive portions of the urban record. Entire satellite cities and road networks sit unexcavated beneath the leaves. Angkor stands as evidence that human ambition, regardless of its engineering complexity, remains vulnerable to the fundamental stability of its environment.